half-life. There are lots of different problems that you'll need to be able to solve using the half-life idea. Okay, so half-life. This represents the amount of time required for a radioactive sample's mass to decay in half. And when it decays, half of the radioactive sample decays into a more stable substance that's referred to as the daughter. The half-life, the rate of this transmutation process, it is not affected by temperature, volume, pressure, or any other environmental conditions. We cannot make it happen faster or slower, but half-life is a pattern, and every radioactive material follows the same pattern, but the amount of time is unique. So take a look here. Here is a graph representing the half-life decay process of cobalt-60. So the half-life cycle, okay? When 0 cycles have passed, your sample, 100% of it is radioactive. And so your starting mass always represents 100% radioactive. And so we could say 100%, or the fraction for that would be 1/1. When you go from cycle 0 to the end of the first cycle, take a look at the mass. The mass has dropped by 50%. So now only half of the sample remains radioactive. And then as you pass from cycle 1 to cycle 2, the mass is cut in half again. So now only 1/4 of the original sample remains radioactive. And it continues on. So at the end of cycle 3, now only 1/8 of the mass is still radioactive. And at the end of cycle 4, now the mass, only 1/16 of the original mass is radioactive. The half-life is the amount of time it takes to go from cycle 0 to 1. And according to this, it takes 5.27 years to go from 100% radioactive down to 50% radioactive. And then to go from cycle 1 to cycle 2, it takes an additional 5.27 years. So to go from 50% radioactive down to 25%, which is cutting it in half again, that it's another 5.27 years. To go from cycle 2 to cycle 3, to go from 25% down to 12.5%, it requires another 5.27 years for this sample of cobalt-60. Now for us, this amount of time, this half-life, this for us is on our table N.